So they tell us that all these triangles are congruent, so they all have the same lengths. So the longer sides are A's and the shorter sides are B's. So I can mark this side a B and this longer side an A, and I can say that the area of the square is going to be, we know that the area of any sort of rectangle, including a square is just a special sort of rectangle, is the area, the base times the height. Now if this is A and this is B, then all the way across is A plus B, right? Like if this were 5 and this were 3, the whole thing would be 8. You added them together. So same thing here, if this is A and this is B, then the whole thing is A plus B. So when we do the area of the square, that's A plus B times A plus B, base times the height. Now just for fun, I'm going to go ahead and FOIL this out because it's going to be useful later. If you need help with foiling, I've got another video for that. So this guy goes to everybody. So A times A is A squared, A times B is A times B, and then he went to everybody, so now it's his turn. B times A is the same as A times B because you can multiply in any order you want. And then B times B is B squared. So if I were to clean this up, I can gather like terms. If I have one AB plus another AB, I have two ABs. And there's just that invisible one there that kind of helps people add those. So one of them plus another of them, you have two of them. So there's a nice cleaned up version of the area of the square in terms of the lengths of its sides. It sounds all scary, but we're digging through it. Now they say, well, find the area of a square in a different way. Okay, fine. So you could also get the area of this whole big square by taking the area of this middle square, right? Middle square, and then adding all 4 triangles. So plus 4 triangles. All right, so if we want to find the area of the middle square, it's a square, so if this is C, then that must be C as well. So base times height is C times C is C squared. Then the area of a triangle is 1/2 the base times the height. So for one triangle, I have 1/2. Its base is A and its height is B, so long as they're perpendicular. Remember, you want to measure heights perpendicular to their base. So A times B, so 1/2 the base times the height. And then remember, we have 4 of those. So it's 4 times 1/2 times the base times the height. So it's the middle square plus the 4 triangles. So it's the C squared plus, you can multiply these in any order you want. 4 times 1/2 is 1/2 of 4, that's 2. So that's C squared plus 2AB. Now, the moment of truth, the area of this big square didn't change no matter how we tried to find it. So the area of the square should equal the area of the square. So this should equal that. So let's do that. A squared plus 2AB plus B squared, got that from there, should equal C squared plus 2AB. All right. Well now, if we just play with this a little bit, we got 2AB on both sides. So if we were just to subtract 2AB from both sides, you can totally do the same thing to both sides, perfectly legal, it goes away. And you get A squared plus B squared equals C squared, which you knew was our goal because they wanted us to prove the Pythagorean Theorem, and that is what that is. Check, done.